Question 9. A student was given a powder made from a mixture of anhydrous, that just means dry barium chloride and anhydrous dry magnesium chloride. The student dissolved. Every time I see barium chloride, I know what's coming. Barium chloride reacts with sulfuric acid to make barium sulfate, which is a white solid. So the test for barium chloride is sulfuric acid, or barium sulfate is the test for sulfuric acid or sulfates. So barium chloride reacts with anything with a sulfate, like sulfuric acid or any other sulfates, and makes barium sulfate as a white solid. It's actually used in barium meals. You'll take barium sulfate and swallow it so that they can photograph, or x-ray rather, your gut, so it sits in your gut as a solid which can be x-rayed then and appears on an x-ray plate, so you can actually have a look and see if you've got any ailments, any illnesses. You can x-ray the soft tissue like your gut or your intestine by putting barium sulfate solid down there as a barium meal. Anyway, so barium chloride and anhydrous magnesium sulfate. The student dissolved 1.056 grams of this mixture in water and added sulfuric acid. Here we go, it's going to make barium sulfate. The white precipitate, the barium sulfate formed, was filtered off, washed and dried. The mass of the solid was 0.764. We'll probably make some magnesium sulfate as well, but magnesium sulfate is soluble. Identify the white precipitate, that's barium sulfate then, used in barium meals, and calculate the percentage by mass of the magnesium chloride in the powder. So I'm going to have to work out the mass of the barium sulfate in there and then subtract it from the total mass of the mixture and work out the magnesium chloride. Okay, let's have a look what I've got so far. So the student dissolved 1.056 grams of the powder, and I got a mass of solid was 0.7764 grams. So the barium chloride and the sulfuric acid make barium sulfate. That's the white precipitate. That will get me 1 mark. So now I've got the mass of the white solid, which was 0.764. I can work out the MR of barium sulfate using a periodic table, 233.4. So moles of barium sulfate is the mass divided by the MR. I know the number of moles of barium sulfate. Where's the barium sulfate come from? It's come from the barium chloride. So the number of moles of barium chloride must be the same. I must have 0.003273 moles of barium chloride if it's made barium sulfate, 0.003273 moles. So I now know the number of moles of barium chloride. I know the MR of barium chloride because barium chloride is BaCl2. By the way, barium's in group 2, so it's 2+. The sulfate ions are 2-. 2+ barium, sulfate SO4, 2-. They cancel each other out, BaSO4, whereas barium chloride, Ba2+ for barium in group 2, loses 2 electrons. 2 electrons inside shell, loses those 2 and becomes 2+. Chlorides in group 7 gains 1 electron in group 7, Cl-. 2+ Cl-. I'm going to need 2 Cl- to balance up with the barium 2+, BaCl2. Its MR is 208.3. So now I've got the MR of the barium chloride, I've got the number of moles of barium chloride. Moles is mass divided by MR, so moles is 0.3273 is the mass divided by the MR, 208.3. So the mass of these two numbers multiplied together, 0.003273 times 0.208.3, 0.6818 grams. And now know the mass of the barium chloride in the mixture. Now the mixture had a mass of 1.056 grams. So I know the mass of the mixture, I know the mass of the barium chloride in there. If I take the total mass of the mixture, 1.056, and I subtract the mass of the barium chloride in there, 0.6818 grams, I end up with 0.3742. That's the remaining thing in the mixture, which is magnesium chloride. So I've got 0.3742 grams of magnesium chloride. I've worked out the mass of magnesium chloride. Oh, it wants me to do a percentage now. So I've got 0.3742 grams of magnesium chloride in a total mass in the mixture of 1.056. So I divide the smaller by the larger, multiply by 100%, 35.4%.